now we've got a beautiful function to create a model for us, and we've actually used it already. We've instantiated a model and got the summary. You might be looking at this like what's going on here, even looking at this like what's going on here. So let's go through this step by step and figure out what's actually happening. So first of all, we instantiate a model. So set up the model layers by using model equals tf.keras.sequential. What's happening here? A linear stack of layers. So when it says that, what it actually means is it's just a stack of layers that's going to take some sort of input, find patterns in that input, and then have some sort of output. That's what the linear stack of layers means. So if we look here, what's the first layer? It's going to run from top to bottom. And here we go. Here's another Colab error. You might see this. Hopefully it fixes itself. Otherwise, we can fix that later. The first layer is hub.keras layer model URL. What this is saying is it's telling TensorFlow Hub to create a Keras layer. So what we're doing is we're using Keras to build our deep learning model. It's telling it to create a Keras layer of model URL, which is our MobileNet v2 architecture. So you might be wondering, what's going on with MobileNet v2? And why do we only have 2 layers? Well, let's check that out. Let's go MobileNet v2 architecture. So here we go. Review, MobileNet v2, lightweight model image classification. So this is what I do when I'm trying to figure out what's going on with a model that I'm using. Maybe I've found a model from TensorFlow Hub, or maybe I've seen a tutorial or using some sort of model. I'm trying to figure out what's happening. So we got MobileNet v2 convolutional blocks. Now, if you wanted to check out that, you might want to look up, this is conv is short for convolution. So you might want to go, what is convolution neural network? So I'll leave a great resource for you to check that out, but here's essentially what's happening. That's a good image, actually. Oh, another Medium article, beautiful. So here's what's happening. We have an input image, and then MobileNet v2 has a whole bunch of these type of layers built into it. So they're going to look at the input image, do some data transformations on it, and then output it to something, aka a list of numbers. So this is what our job is. If we come back to the keynote, we've prepared our inputs and we're passing it to the machine learning algorithm, in our case MobileNet v2, and it's going to output something. So the beautiful thing about transfer learning is that all of these parts are taken care of for us using MobileNet v2. We've defined our inputs, and this is what we want at the end, some sort of output. Now let's come back to this review of MobileNet v2. And it's okay if you don't fully understand about what's going on here. This is part of the experimentation of deep learning and machine learning. It's figuring out what's going on, what is happening to our data when we transform it. Our first focus is to always write working code and then figure out what's happening after that. If we want to dive deeper, we can. So the overall architecture of MobileNet v2, it takes an input of size 224 squared times 3, aka the height and width of our images times color channels. It does a whole bunch of transformations. So takes this input, does transformations like this. Okay, and then finally it's going to output a single list of numbers that are a size of 1280. So that's the last layer. And now you'll see this overall architecture in papers and whatnot. Hopefully, if they're a good paper, they've included this. And if they're an even better paper, they've included code. And you'll see this and you'll be wondering, what is this? Well, it's something like this. Again, you'll be wondering, what is this? So let's have a look what it might look like in NumPy. So if we go outputs equals NP, let's just do ones of shape equals 1, 1, 1280. And then outputs. So it's just going to be a long list of different numbers. But 1280, we don't actually need that, right? This is where our dense layer comes in. This is where our outputs come in. We want our outputs in the form or in the shape of 120 because that's how many labels we have. So let's put this all together. We have an input of an image. MobileNet v2 is going to go through for us and find all the patterns and then condense them into one long array of numbers, 1280 long. But then this is the beautiful thing about transfer learning is because all of this has been implemented for us, all we have to do is say, hey, actually, instead of that 1280, we want our output to be in the shape of however many labels we have. And you might be wondering now, okay, what does dense do? Let's look at the docstring. Just your regularly densely connected NN layer. Well, thanks docstring, that actually doesn't make too much sense. But you might be wondering what the activation is. Now, softmax, let's check that out. What is softmax? And this is where you're going to get a whole bunch of mathematical jargon. But let's just go to Wikipedia. Now, if you read that first line, it might sound pretty confusing to you, unless you've got a mathematics degree or something like that. But the main thing here is that after applying softmax, each component will be the interval 0, 1. And the components will add up to 1. Now, we will see this later on, but that's all you have to know for now. And if you're wondering, what softmax do I use? Which activation, which loss function? If we're working with binary classification, the activation function is sigmoid. So we come here, sigmoid. And if we're working with multi-class classification, the activation is softmax. Softmax. So that is what is happening in here. We're creating a Keras model. It's going to run in sequential fashion. The first layer it's going to call is the model URL, which is actually the MobileNet v2 architecture, which has been implemented for us. And within that MobileNet v2 architecture is going to be a series of convolutions, which are going to find patterns in our input images and learn the features of those images. If you're wondering what a feature is, let's come up to an image. Let's take this one, for example. A convolution may look at each pixel in this image and go, okay, there's a vertical line, there's a circle here, there's a circle here, there's a horizontal line here. Now, the thing is, we don't tell the model which of these features it learns. It figures them out on its own. So that's the important takeaway there. That's the whole premise of machine learning, is that it figures out the patterns in these images for us. So we come back. So once it's gone through the MobileNet v2 architecture, it's going to output a single array of size 1280 with all of the patterns that it's learned in an image. But we want to tell, hey, we want to go, no, we don't need 1280 patterns. We need 120. And then we want to use the activation softmax to convert those patterns into numbers between 0 and 1. And then the highest number, so all of the outputs, so it'll be an array of 120, all of those will add up to 1, and the highest value is which one is our label. Now that was a lot to take in, but we're gonna, over the next few videos, break this down even more. So in the next one, we're gonna go through what's happening when we compile a model. So I'll see you there.